let's have another example on Fourier series. Now we have our example 3 under the Fourier series analysis. We are given the periodic function f of t is equal to t squared plus t for t in between negative pi and pi. And f of t is equal to f of t plus 2 pi. So our function is a function of period 2 pi. So whatever we see here says the period. Now we are told to sketch now the graph. We have to sketch the graph from negative 3 pi to positive 3 pi. And if you check in that particular analysis, that would be a graph for around 3 periods. So when you are told you sketch that graph, remember our graph, it repeats itself after a period of 2 pi. So you don't draw it as a continuous graph from negative 3 pi to positive 3 pi. It is a graph which repeats itself after a period of 2 pi. Then after that you're told determine the Fourier series. Always in Fourier series, if you draw your graph, you'll actually see whether you are dealing with an odd function or an even function, or sometime it should be it can be a function which is neither odd nor even. Those three will give you the classification you need so that you know the formula to use for determination of Fourier series coefficients. Now, in this one, let's sketch. The function is f of t is equal to t squared plus t. This is a second degree equation. And in a second degree equation, that is a curve. So we might be having endpoints. But our endpoints of the curve, our endpoints will be joined by a curve. So endpoints, you prepare them the normal way after preparing your endpoints. But now how will you join them? It will be a curve. And for a curve, for you to do curve sketching, you must know some things before you sketch your curve. So in our solution, for the curve, the following should be determined. The following should be determined. The first, we need endpoints of the curve. 2, we need y-intercepts. That is where x is equal to 0. But in this our case, we say, when we talk about y-intercept, we'll be going for a value of function of t. Now, function of t represents our y. Now, t is what is representing x. So, our y-intercept, what we'd like to know now, is where our graph or our curve is crossing the vertical axis. That is what will be our y-intercept. And that is where t is equal to what? 0. We have in number 3, x-intercepts. If y here was a function of x, so I'm putting this one generally because normally most graphs are drawn on xy axis. So x-intercept, that is where y is equal to 0. Then for turning points, turning points, if any, on the interval stated. On the interval stated. If any on the interval stated. So you will be able to sketch your curve if all these are determined. So let's now get our endpoints of our curve. Let's get our endpoints. So endpoints are 1. When t is minus pi, that will be an endpoint. When t is minus pi, our f of t will be equal to what? You now insert minus pi where you have t. So this one, when you put minus pi, you'll end up with pi squared. And you put minus pi where there is this t, you'll end up with negative pi. So that is an endpoint. Are that and when t is positive pi, here f of t will be pi squared, but plus pi. So that is that. Those are the endpoints. So we want to get when t is equal to 0. When t is equal to 0. This one will help us in getting points where our curve crosses the vertical axis. So when t is equal to 0, what will be the value of f of t? F of t will also be 0. And it is only at that point. So we say point 0, 0 is where our curve crosses the vertical axis. Now we have when f of t is equals to 0. In other words, if you're on xy axis, when now y is equal to 0. When y is now equal to 0. So what do we have? When f of t is equal to 0, that is t squared plus t will be equal to 0. So when we solve this equation, this is t into t plus what? 1 is equal to 0. When we factorize, so when we factorize, we get that. When you multiply two numbers, they give you a 0. Either one of them is a 0. So we say t is equals to 0 or t is equals to what? Negative 1. So the points now where our curve crosses the horizontal axis is point 0, 0 and point 0, negative 1. That's where it is crossing our horizontal axis, or the betterly known betterly known x-axis. Now turning point occurs. Turning point occurs when dft dt should be equated to 0. That is at a local maximum or a local minimum. So we will now differentiate our function of t. Our function of t is equal to t squared plus t. This implies d dt of what? T squared plus t. This one should be equated to 0. This implies what? 2t, if you differentiate now, 2t plus 1 should be equated to what? 0. So from here t is equals to what? Negative a half. So when t is equal to negative a half, f of t will be equal to what? F of t, we now take negative a half and insert in our t squared plus t. So f of t will be equal to now negative a half v square plus negative a half. So this one gives us now negative a quarter. That is negative a quarter. So that's what we have. So the turning point is at turning point. Turning point is at negative a half, negative a quarter. At negative a half, negative a quarter, and it is it a maximum or a minimum? If we differentiate this one twice, the first derivative was 2t plus 1. If we differentiate it twice, it will be 2. When the second derivative is positive, then we are dealing with a minimum. So we say, and it is a minimum. It is a minimum. And it is a minimum. Now we are ready now to sketch our curve or our periodic function. So the value pi always, you know, is around 3.14 units. That is pi. Pi is normally 3.14 units, about that value. So we can take pi, if you round it to be approximately equal to 3, when we are doing our sketching. Yeah. So we can say we have 1 here, 2, and there we have 3. So we insert a pi. We have 1, 2, and then 3. You insert a pi for purpose of sketching, because what we want to see is the shape of our curve. We are only sketching. We are not drawing to a nice scale. So that is it. So we were told we do it. We were saying now this one represents 1, 2, 3, and whatever. We have our now endpoints. We have negative pi. And we have this value, pi squared minus pi. We know that will be a positive value. Even if you punch it from your calculator, it's a positive one. Is it not so? And this pi squared plus pi is also a positive one. But this one is a greater positive than that one. Yeah, so even if you punch from that calculator, that's what you will get. So we have here, we can indicate here we have maybe pi minus pi squared minus pi. And somewhere here we indicate pi squared plus what? Pi. This is the graph of function of t. That is the graph of function of t. So now we put endpoints. When our t is minus pi, our function is here. It is going up to this point. So that is the point. That is an end point. And when our t is pi, our f of t is this one. So we are going up to that point. Yeah, so that is it. Yeah, we plot there. So that is those are the end points. Then our graph will cross our vertical axis at a point 0, 0. That is the said like y-intercept. So this is where it's going to cross. Where will it cross our horizontal axis, the t-axis, the normal x-axis? It is where? We now insert. It is 0. We have 0, 0, 0. When t is 0, f of t is also 0. That is that point. Now again, when t is -1, f of t is also 0. So point -1, because this is -1. This is where we have our -1. So -1, 0, 0, 0. Those are the points that we are going to now have our curve crossing the horizontal axis. Now our turning point is at a point -1/2, -1/4. So if this one is 0, this is -1/2, -1, so -1/2 is in between here. So we have -1/2 somewhere there, -1/2. And on the y portion, we just need a -1/4. So some small portion down there. So this is the turning point. So -1/2, -1/4. So we have everything. So we can now sketch our curve. So we simply start and join these points with a smooth curve. With a smooth curve. And that is now our graph for only one period. And then if you have drawn one, the graph repeats itself. So this other side, you do a repetition. You are told you go up to 3 pi. So we normally start from somewhere there. At this point, that's where we start. Then we come down somewhere there. Then we get the turning point. Then we are there. When we reach here, we should be somewhere here. So this one will now start this way. Proceed to the turning point, and then we go upwards. So that is now the 2 periods of that particular function. Remember, it is a curve. It is not a straight line. You join those points with a smooth curve. On this side, we must have reached somewhere, because here we are starting. We normally reach when we are at some point. And because this side, we are only going up to -2 pi here. That is -2 pi. So our function will now be crossing there, crossing, and then we turn. So that is another one. But in your book you can create, because your book has got nice lines and squares made and passed with some standards. You can be able to draw it and have it nicely done. So this is now the graphical representation of our function of t, which is periodic. You are through. Any question on this sketch? Is there a question on plotting the curve? No question, eh? So let's now go for the Fourier series. So from the graph, this function, which type of a function is this? Is it odd? Huh? Is it even? So it is neither. Huh? This is neither even nor odd. So this is a function. It is not symmetrical about the vertical axis, and it is not symmetrical about the origin. So it is a function which is neither odd nor even. Therefore, in evaluating Fourier series coefficients, we will now evaluate all the Fourier series coefficients. That is A naught, an, and bn. So we say our f of t now will be given by a naught all over 2 plus summation n starting from 1 to infinity an cos n pi t all over n plus bn sine n pi t all over n. But 2L is equals to what? 2L is equals to 2 pi? 2 pi. So L is equals to pi? Pi. Our A naught, because we are using general formula, will be given by 1 over L. We are integrating from C to C plus 2L, f of t dt, where C normally denotes the initial starting point of our word, of our periodic function, as stated from the analytical representation. And from our analytical representation, our f of t was starting from minus pi. This is the initial period. So it started from minus pi. So that C is minus pi. So we say this one will be equal to 1 all over what? Pi. We are integrating from minus pi to minus pi plus 2 pi, which will just be pi. So this is just a formula, but the main thing here, you should integrate over the whole range. That is from negative pi to what? Positive pi. So our f of t here is the same. There we don't have 2 intervals. It was only 1 interval. So we write that function. It is t squared plus t. And then we say d what? dt. When we integrate this, we get 1 over pi. The integral of t squared will be t cubed all over what? 3. Plus t squared all over what? 2. Then we put from minus pi to positive pi. So our A naught will then be equal to 1 all over pi. We are inserting our limits. When t is pi, we get pi cubed all over 3 plus pi squared all over 2. Minus, when inserting lower limit, you're minusing, and then we say minus, when you put minus pi, when you cube it, it will be negative pi cubed. So negative and negative will become positive. So positive pi cubed now all over 3. We have a minus for this one because we're inserting a lower limit. But negative pi, when you square, you get positive pi squared. So it will be pi squared all over 2. So our A naught will now give us 2 pi squared all over 3. 2 pi squared all over 3. This one will cancel this. This will be 2 pi cubed all over 3. And then you divide by pi, we get 2 pi squared all over 3. So that is our A naught. We now move to AN. AN will be 1 all over L. We integrate from c to c plus 12. F of what? F of t. But we have cos n pi t all over n, then dt, which gives us now 1 all over pi. We are integrating from minus pi to positive pi. Our f of t is what? T squared plus t. This one will become as cos what? Cos nt, because L is pi. So dt. Here we'll require integration by parts. Because this function and that function, they are not related to each other in any way. So we say, let u be equal to what? T squared plus t. And let our dv to be equal to cos nt. So du will be equal to what? When we differentiate here, we get 2t plus 1. And now multiplying dt. Because du dt is what is 2t plus 1. So if you make du the subject, it is 2t plus 1 dt. Now our v will be what? 1 all over n. Sine nt. Sine nt. So this one will be equal to 1 all over pi. We write our uv. U times v. U is here, v is there. So it will be 1 all over n into t squared plus t. Now multiplying sine nt. We put our limits from minus pi to pi. Minus from integration by parts formula. Then the integral of from minus pi to pi, we have v du. So we have 1 all over n into 2t plus 1 into sine nt. Now multiplying dt. So v multiplied by du. That's what we have. Then we close the main bracket. Now, as you can see, if we insert pi here, this will be sine n pi. If we insert negative pi, it will be sine negative pi n. The negative can come forward, so we'll remain with sine n pi. But any sine n pi is normally equal to what? 0. So that one, the whole of this thing now comfortably approaches what? 0. So we have our an now will be equal to now 1 all over pi. We are integrating. Oh, that negative. Just a minute. Negative 1 all over n is a constant. It can be taken out this way to join this one, which will be 1 all over pi. So it will be a negative 1 all over pi n. Then we have the integral from minus pi to pi. Then what is remaining is 2t plus 1 multiplying sine nt d what? dt. Multiplying sine nt dt. Here we need some integration by parts. So we let u to be what? We let u to be 2t plus what? 1. And we let our dv to be equal to what? Sine nt. So du will be equal to 2d dt. And our v will be equal to minus 1 all over n cos nt. If you integrate a sine, you get a negative cos. But you have to divide with the coefficient of t. So that is it. So our an will then be equal to negative 1 all over pi n. The integral, onto the integral, we put a bracket to receive our integration by parts. Integration by parts details. So we have negative 1 all over n, that is v, multiplying the u, which is 2t plus 1, multiplying u. Then we have cos nt. We are only writing uv. Then we have our limits from minus pi to positive pi. Minus from integration by parts formula. And this minus from v will become a plus. Is that okay? Now we have 1 over n is here, which will still be a constant, can be left outside the integral sign. And 2 here is also a constant, which you can also leave outside the integral sign. That is 2. 2 is a constant. Negative 1 all over n. You have used the negative here to bring this one as a plus. N is here. So what is remaining here will be what? Cos nt multiplying dt. And we are integrating from minus pi to pi. Is that one in order? Now we know from our details, when we are recalling our integration, the integral from minus pi to pi, cos nt dt, gave us what? A 0. So this one comfortably approaches what? A 0. So that one is gone. So we are through with our integration. We are only inputting the limits. So this one will be equal to, now we have this times this. We'll have here 1 all over pi n squared. And now we start inserting our limits. Our limits now, when t is pi, we'll have a scenario of 2 pi plus 1 multiplying cos n pi. This negative to mepeleka injet is not there, so we must have a minus there. And then now we are inserting. We are inserting here. Where there is t, we put negative pi. So it will be minus 2 pi plus 1. Multiplying cos negative pi n. Where there is t, we insert this. So that is that. And that's all. So this will be equal to 1 all over pi n squared into, we are expanding, removing our brackets. We have 2 pi cos n pi. We have plus cos n pi. We have minus and a minus positive. Positive 2 pi cos. Cosine of a positive pi n and cosine of a negative pi n, they are the same. So this one will be cos pi n. Plus a negative. This is negative times 1, which will be negative 1. Negative 1 times this is minus cos n pi. So from this one, this will cancel this, and this will add on to this. So we'll have a scenario of 4 pi cos n pi. 4 pi cos n pi, all over pi n squared, which is equals to 4 all over n squared, multiplying cos n pi, which is the same as 4 all over n squared, multiplying negative 1, power what? Power n. Multiplying negative 1, power n. And this is defined for all values of n. If you input 1, you get something. You input 2, there is something. You input 3, there is something. So this one, there is no need of having a division or saying when n is odd, we get this one, or when n is even, we get some other value. There is no need because we don't get some zeros. If we are supposed to get some zeros, it's when we say when n is odd or when n is even. So this one is now maintained the way it is. Find the value of Bn. Bn will be given by 1 all over L. We integrate from C to C plus 2L. F of t sine and pi t all over L, then dt, which will be equal to 1 all over pi. We are doing it from minus pi to positive pi. The function is the same. The interval is 1. So it is t squared plus t. And now this will be sine nt dt, since L is equals to pi. So here we need also integration by parts. We let u to be t squared plus t. And we need dv to be sine nt. du will be equal to 2t plus 1. And v is equals to minus 1 all over n cos nt. So this will be 1 all over pi. We put a bracket. We write u times v. U times v. Yes. So we have this one as 1 all over pi. 1 all over pi uv. It is minus 1 all over n into t squared plus t. Now multiplying cos what? Nt. We are doing it from minus pi to pi. Minus from integration by parts. And this minus, it will be plus. Now we have 1 all over n. 1 all over n is a constant. We can put it outside an integral sign. So we have inside here 2t plus 1, which is from a du. Our du was this dt. Add the dt here. That one should be a dt. So multiplying cos nt and then dt from du. Dt from du. So that is that. So let's insert our limits as we proceed. 1 all over pi. 1 all over pi into 1 all over pi into, I can see 1 all over n is common. I can take it out fast. 1 over n is here, and another 1 over n is there. So we say this one will be 1 all over pi n into. Now we remain with the negative t squared plus t cos nt from minus pi to pi plus, yes, the integral from minus pi to pi, 2t plus 1, multiplying cos nt. Now we have that one dt. We close the bracket. So before we insert those limits, we can do some integration by parts here. we let u to be equal to what? 2t plus what? 1. And we let our dv to be equal to cos nt. So du will be equal to dt, and v is equals to what? 1 all over n sine nt. So RBN we can then write to be equal to 1 all over pi n into now. We can start inserting now. It will be minus into pi squared plus pi. When we input the upper limit, cos n pi. Now plus minus. The minus, when inserting lower limit, will clear this minus. So it will become positive. And then when we input negative pi where there is pi squared, it will be plus. Now it will be pi squared minus pi. Where there is t, we input now minus pi. Now this one will be multiplying cos negative pi n. So we have cleared with these first limits. We go to that one. We say plus what? uv, which is plus 1 all over n. Our u is 2t plus 1. Now multiplying sine nt from v. That is from our v. Then we have from minus pi to pi. Minus from integration by parts. So du has got a 2 and v has got 1 all over n, which is a constant. So I will say minus 2 all over n, the integral from minus pi to pi. Then what I remain with is sine nt. Now multiplying what? dt. And now we have closed that bracket, the major bracket. So from here, we can say this is 1 all over pi n into. Such an integral from minus pi to pi, multiplying sine nt dt, that one comfortably approaches 0 from our recall. So this one goes to 0. When you input limits here, you will get sine n pi. And when you input this, will be sine negative n pi. So all will also approach what? 0. So we only remain with this portion to analyze. So we are opening these smaller brackets here. We'll be having what? Minus pi squared cos n pi. Minus pi squared cos n pi. Then we have minus pi cos n pi. Minus pi cos n pi. We have here minus, and this one will also be a minus. Then we have plus pi squared. We have plus pi squared, multiplying this, and that's just now another cos n pi. Then we have a minus. A minus pi cos n pi. Then we close that bracket, which simplifies to what? This one will simplify to, what do we get here? This one will simplify to, this one and that one goes. So we have negative 2 pi cos n pi all over what? Pi n, which simplifies to minus 2 all over n cos n pi, which we said negative cos n pi can be replaced by what? Negative 1 raised to power raised to power negative 1 raised to power n plus 1. Negative cos n pi. We had it in our not carefully issues that we were some things that we are preparing for our analysis of Fourier series. So 2 all over n negative 1 power n plus 1 plus 1. So that's what we have for our Bn. So let's proceed now with now writing down the Fourier series. Writing down the Fourier series. So our f of t will now be equal to n out all over 2 plus summation n starting from 1 to infinity. N starting from 1 to infinity. Then we have an cos nt. This is because it is a function of period 2 pi. That's why it is behaving like this. So a naught divided by 2 in our case would be equal to what? A naught divided by 2 in our case would be equal to, that is now pi squared all over 3. Because it was 2 pi squared all over 3 divided by 2, you get pi squared all over 3 plus summation n starting from 1 to infinity. Remember, all these values we did for this particular function, they were all appearing, the Fourier series coefficients were all appearing for both odd and even. So there is no need of classifying that we are dealing with odd or classifying that we are dealing with even. They are all the same. So we say this is summation. Then we have our an. An was 4 all over n squared into negative 1 power n. Now this one is multiplying cos n t. Bn is what? 2 all over n into negative 1 power n plus 1. Now multiplying what? Sine nt. Now remember, all values of n are being used here. And therefore, that is the Fourier series representation. But sometimes you can also write indicating some few terms of the series. So we can now write the series and say this is pi squared all over 3 plus 4. 4 is a constant here. It won't change when n is changing. So we say 4 into. We want to write the cosine series first. So when we write the cosine series, when n is 1, it will be negative 1. Negative 1 power 1 is negative 1. So all over 1 is square. Cos what? 1t. When n is 2, it will be plus. 1 all over 2 cos what? Cos 2t. When n is 3, it will be negative 1. 1 over 3 cos 3t. When n is 4, it will be, oh, this is 2 squared, 3 squared. We are dealing with the n squared. So plus, when n is 4, plus 1 all over 4 squared, cos 4t. Because we cannot write all, we say plus others. Now plus, 2 here is a constant. 2 is a constant. And now when n is 1, this will be just positive 1. 1 all over 1 sine 1t. When n is 2, this one will now move to negative 1. Negative 1 all over 2 sine 2t. Next will be positive 1 plus 1 all over 3 sine 3t. Then minus 1 over 4 sine 40. So that's what we'll have plus others. If you like, now you can write this one again nicely. It will be pi squared all over 3. We know this one will have a negative. And in a bracket, we should always not have a negative starting. So we can push this negative outside here. So it will be what? Minus 4 into. So this one will become positive cos t. This one will be a negative 1 all over 4 cos 2t. This one will be positive now, 1 all over 9 cos 3t. This one now will be a negative 1 all over 16 cos 14 plus others. Plus now 2 into sine t. 1 divided by 1 is just 1 minus a half sine 2t plus a third sine 3t minus a quarter sine 40 plus others. Assume you are now answering a part 3, which we did not indicate there. But let's assume you are answering part what? Part 3. So you are told in now part 3, by letting t to be equal to pi, show that pi squared all over 6 is equal to summation n starting from 1 up to infinity, 1 all over n squared. We're told to show that that one is happening. Now we go back to our graph and check all this. So I'll draw a small one here for us to use. Although you have it in your book, it is there. It is only that on my board it is now missing. On my board it is now missing. So we had here pi squared plus pi. We had here pi squared minus pi. So we had a point here, pi. So this one went here. So I'm only drawing where we are going to take when t is equal to pi, so that I show you something. Now, when t is equals to pi, you can see, if you go back to your graph, one person will read it here, and another person will also read it there. They are all values that occur when t is equal to pi. If you read it graphically, so you can go and maybe read from this point, or you can go and then read from that particular point. So there are two values for it. So we say this is a point where this graph dropped drastically to another graph. So it is a point of discontinuity. discontinuity. So when we have a point of discontinuity, we say a point of discontinuity. So f of t at a point of discontinuity, at a point of discontinuity. Will be given by f of t as we move in forward direction plus f of t as we move in backward direction or negative direction, then we get the average of two values. That is, we get the average of those two values. There is forward movement and backward movement, or positive sense of movement and negative sense of movement. Hii kitu plus inaandikwa mbele ya hiyo t sio nyuma, na hii inaandikwa mbele ya hiyo t. Yeah. So that is how we are going to get our function of t at a point of discontinuity. This has come about because here at t equal to pi, we have seen it is going to be a point of discontinuity. So from this, we now go back to our series. Is that okay? So f of pi, where there is t now, we insert pi. We had pi squared all over 3. We had plus summation, and starting from 1 to infinity. We had 4 all over n squared into negative 1 power n, multiplying cos nt. Now t is equal to pi. Now, the one for sine nt will have sine n pi. And we know sine n pi will be 0. So the part of sine function has been what? Deleted, being that sine n pi is equal to 0. So this is what is remaining in our word, in our statement, when we substitute for t equal to pi. So we want to go for f of pi. When you go back to your graph, we can read when we are moving towards that point, this is positive movement. We are approaching which value? Pi squared plus pi. So that is the function as we move in the positive direction. You see, that is it. We are on this particular graph. And as we approach t is equal to pi, we have our function of t is pi squared plus pi. Now, when we are moving in a negative sense or in a backward direction, you are now moving towards that point, but moving now from right to left. So this will be a negative movement. So which value do we approach? We approach pi squared minus pi. So we say plus pi squared minus pi. And then we divide by what? 2. This process can only be done where there is what? A point of discontinuity. Don't do it everywhere. But even if you do it everywhere, if it is not a point of discontinuity, when you move from left and from right, what will happen? You're going to be having the same values. If it is not a point of discontinuity, this one will be, let's say, if this one is pi, that other one will be pi. If you divide by 2, you still maintain your pi. But now, this is a point of discontinuity. You're going to get different answer for this. So this is pi squared all over 3. This 4 can come out. It can pass the operator. The operator is the summation sign. And we remain with 1 all over n squared. And we have negative 1 power n. Cos n pi is also another negative 1 power what? N. So what do we have here? We only remain with pi squared from this side. It is just pi squared, which is equals to pi squared all over what? 3 plus 4 summation n starting from 1 to infinity. Negative 1 power n times negative 1 power n, it will be negative 1 power 2n. According to laws of indices, And we know 2n is an even number. Negative 1 raised to an even number. The answer is positive 1. So here we just have positive 1 all over n word square. Our main aim is to have this one left on that side. That is our main aim. So that we can be able to show that this one is actually equal to that. So everything that is from here up to there, we have to move them to the left-hand side. And we are moving them mathematically. So this is pi squared. If we bring this one this way, we say minus. Pi squared all over what? 3 is equals to 4. Then we have summation. N starting from 1 to infinity. 1 all over n squared. This is now 2. It will be 2 pi squared. All over 3. Is it 2 pi squared all over 3? Yeah, it's equals to 4 summation. N starting from 1 to infinity. 1 all over n word squared. From there, we move this 4 this way. So we divide both sides by 4. So this will be 2 pi squared all over 3 times 4 will be equal to summation n starting from 1 to infinity. 1 all over n squared. So this one now gives us pi squared all over 6, which is equal to summation n starting from 1 up to infinity. 1 all over n squared. And then we say, hence shown. So this is how we deal with points of infinity of discontinuity when you are trying to input your values so that you can have some analysis according to summation of some numbers. So we are through with that one. Now we can now write some document which will now help us in our next lesson. And if possible, we can have one example. You get that? Yeah, so we're going to our next. So by now, we are saying, if you are given something involving a curve, you can actually work on it, yeah, and proceed and clear. So last time to learn some special functions, some were even, some were odd, and like so, which we cleared nicely. Now let's go to what is known as half-range Fourier series.